Hello and welcome to the Gravel Ride podcast, where we go deep on the sport of gravel cycling through in-depth interviews with product designers, event organizers, and athletes who are pioneering the sport. I'm your host, Craig Dalton, a lifelong cyclist who discovered gravel cycling back in 2016 and made all the mistakes you don't need to make. I approach each episode as a beginner to unlock all the knowledge you need to become a great gravel cyclist. Today on the podcast, I'm welcoming Randall Jacobs to the show for an interview. You may very well know him for his efforts in the Dirt episodes as my technical sidekick, as well as an increasing number of standalone interview episodes that he's handling on behalf of the podcast. I very much appreciate his technical orientation and his passion about the gravel cycling community. But today I wanted to get him on the show to talk about his new efforts with his company Lōgōs Components. He's introducing 3 new wheels this month to the gravel cycling community. We wanted to do an episode obviously touching on the new company, but also as something that's standalone for anybody who's interested in upgrading their wheels or purchasing a wheel set for their gravel or mountain bike. I think there's a lot of nuance in the hubs, spokes, and rims that you can learn from this show that you can take across any decision you're making with any of the fine rim and wheel manufacturers out there in the world. So with that, before we jump in, I need to thank this week's sponsor, Hammerhead, and the Hammerhead Karoo 2 bicycle computer. The Hammerhead Karoo 2 is the most advanced GPS cycling computer available today with industry-leading mapping, navigation, and routing capabilities that set it apart from other GPS options. Free global maps with points of interest included like cafes and campsites means you can explore with confidence and on-the-go flexibility. I've talked about how I've been appreciating the Hammerhead and how increasingly I've taken the time to customize each screen. My latest way of geeking out was with my rival access componentry. You can actually track the number of shifts in any given ride. Obviously not mission critical information, but I just thought it was kind of interesting because as you think about it, you do shift more or less depending on the undulation of the terrain out there. I very much appreciate Hammerhead's bi-weekly software updates. I always look forward to it. Sometimes it's things that are like no-brainers, like they've been improving their points of interest along the way. And other times it's deep tech that, I perhaps don't have a need for today. But I very much appreciate the fact that they update it constantly because it's just something that gives me confidence that I've always got the most up-to-date technology on my bicycle computer. Recently, I think I mentioned I've been doing some exploring in my hometown. I love and appreciate that return to home feature. I was out on a route actually when I was traveling, and I wasn't exactly sure how I was going to get home, and I was pretty beat, and I just navigated to return to start, and it gave me the most bike-appropriate route home, which was very much appreciated as I was cracking in the heavy Tucson heat. For a limited time, our listeners can get a free heart rate monitor with the purchase of a Hammerhead Karoo 2. Simply visit hammerhead.io right now and use the promo code TheGravelRide at checkout to get yours today. This is an exclusive limited time offer for our podcast listeners, so don't forget to use the promo code TheGravelRide. Add that free heart rate monitor into your cart, and when you purchase the Karoo 2, you'll get that heart rate monitor for free. Go to hammerhead.io, add both carts and the promo code TheGravelRide. With that said, let's jump right into my conversation with Randall. Randall, welcome to the show.
Great to be back on, Craig. Been looking forward to this conversation.
I feel like I owed you a more specific welcome because unlike our In the Dirt episodes, this one's a little different. We're going to go deeper, and I think it's important. Many people who listen to In the Dirt are aware you're my sidekick. You're someone who's got a little bit more technical knowledge about the bike industry and bike components, et cetera, than I do. And we're just a good muse for each other on our journey in this sport. But in today's episode, we're going to go a little deeper about you and your companies.
Yeah, it's a bit of a throwback. It reminds me of, I think it was June 2018 when I first came on the pod, which is when you and I first got acquainted as well, and this friendship that's blossomed from that. So it'll be fun to have another such conversation.
Yeah, it's super early days. And I remember, part of that journey was me ending up selecting a thesis bike, in part because I just found you to be very thoughtful as a product designer. And I would love for the listener today, who may be coming at it having not listened to that original episode, to just understand a little bit more about your background in the bike industry and your philosophy around creating bicycles and componentry.
Sure. There's a deeper dive that we did in that aforementioned episode, but long and the short, I've been riding, as many of us have been riding since I was a kid. Really got serious into it around age 18, started racing. I was working in a bike shop here in the Boston area. Then later on, I got to pack fodder pro status on the cross-country circuit for a couple of years, which was a lot of fun. Dirt bagging out of the back of my Honda Element around the country. And from there, I did some supply chain work outside of the bike industry in China. Lived there for some years, picked up Mandarin.
Hang on, right, Randall. So how did you get into supply chain?
So let's see. I was 21 and getting ready to finish college, and decided to go and do a study abroad. I was at Zhongshan University in Guangzhou and met a man who became a good friend and a mentor, who hired me to work for his trading and manufacturing company. It was a Chinese company, Chinese-owned, Chinese management. So I was the only non-Chinese on the team. And I was charged with first business development, but later on got deep into product development. I was brought into all the key meetings with our big vendors and learned the ropes of how it works at that very deep level. And at the same time was picking up a lot of not just the technical language and understanding of how things are made across a broad range of sectors, including technologies that apply to bike, but then also the cultural elements of successfully architecting a supply chain. So that was a pretty formative period for me.
I bet. Yeah, it's so huge. And one of those things that it's easy, if you've never got into the manufacturing world, to not think about, but really understanding the culture, and in particular in your case, understanding the language and developing a fluency of communication in the native tongue. It's just so immensely helpful in greasing the manufacturing wheels, so to speak.
Oh, absolutely. Frankly, none of what the companies I've been involved with do would be possible without having learned the language, and later did a graduate degree in US-China relations. So learning not just the culture from a firsthand perspective, but also a lot of the history, a lot of the philosophies, reading some original texts very slowly with the dictionary, but reading them nonetheless. It all makes a big difference when you're trying to build a deep trust-based relationship with a party who has a very different background.
Yeah, 100%. Now, was the bike still part of your life during this period, or had you shelved it pursuing your professional vocation?
So I was riding a bit, not a ton, but I was good friends with the owner of the biggest bike shop in Zhuhai, a couple hours outside of Guangzhou, where I had lived when I first went to China. Was teaching English for a period. He's still a good friend. We've actually done some bike packing together, and it was interesting. He was someone who doesn't speak much English at all. So I've only ever spoken Mandarin with him. And this is saying in Chinese, it's like a duck talking to a chicken. And that was our relationship at first, but we were unified by this love of the bicycle. And over time, I obviously learned to communicate. We had a lot of shared experiences. So,
and then did you find yourself drifting back with interest into the bicycle industry proper at some point?
That kind of came later. I got to a point in my career where I graduated from grad school, going through a lot of life change, life transition, and was just thinking to myself, well, what is that kind of nexus of things that I'm good at, that I'm knowledgeable about, that I care about, that resonate with me and my lifestyle, and that I can get paid to do. And working in the bike industry made a lot of sense because I had the experience as a racer. I had some relationships. Obviously, Mandarin was very useful from a supply chain management standpoint, and also ended up doing some market development stuff when I was at Specialized, but mostly supply chain. And so it's kind of the same way that my decision to go to China, was made. It was, okay, well, here are a bunch of different factors that I can weigh in order to make a decision. And ultimately, bike was like, okay, this makes sense. I can do this, and I can probably do it well, and I can learn this. I can excel at this if I put my mind to it.
So you mentioned that you ended up at Specialized Bicycles out in Morgan Hill. Can you just talk about what your role was there and some of the things you've learned? Obviously, you had supply chain experience. You had the experience over in China, but transitioning to a bicycle-specific supply chain, what were some of the takeaways from that experience, and maybe what were some of the projects of note that you worked on?
Sure. So I should make clear, I wasn't there very long, around a year. Some places are a good fit, some places are not for each of us. But Specialized in a lot of ways is arguably one of, if the not most innovative big brand, also a marketing powerhouse, and marketing is a substantial part of it. But there was a lot of very smart people in the room. And working for a company like Specialized, we were a major account. So even though I was not an executive in the company, I was working with the leadership of the factories that we were buying from on the projects that I was helping to manage. So that was, again, another one of these serendipitous experiences that made it such that when I started my own thing, those relationships are already established. In terms of projects, so the one that probably people know most would be the Diverge, and I was one of the team members on that. I shouldn't overstate my role. And it was an interesting project. I remember riding around on prototypes of that bike, and just the concept of a gravel bike making a ton of sense and being really excited about it. It didn't realize the vision the way that I would like it to have. I think the biggest compromise I saw was there was a different tariff code for frames that can fit bigger than a 35 millimeter tire. So it was like 7% more expensive. And so we constrained the tire size to a maximum 35 millimeter in order to stay under the tariff, because otherwise it's a mountain bike, and there was some protectionist policies around mountain bikes at some point. And then there are various other things that I did on my own bikes later on. I didn't have those constraints.
Yeah, that's so
But those
interesting.
are,
I remember in our
yeah,
earlier conversation back in June of 2018 when you first came on to talk about thesis, and you talked about your history there. And I remember walking away from that conversation just finding it very interesting, the business decisions that get thrown on top of a product designer's vision that end up creating constraints, whether it's the time of year it has to launch or the tariffs that it may incur because it has larger than a 35 millimeter wheel tire size. It's super fascinating and interesting. And I can see why, knowing you as well as I do, that you don't want to be constrained by those criteria. You ultimately, your heart is in creating the best product possible.
yeah. And of course, there are constraints in what I do too, right? I'm not going to make I didn't make a $10,000 bicycle. I made a bicycle that did everything that I think a bicycle needs in order to not really be dreaming about the $10,000 bicycle at night, right? So there's different constraints when you have to have a complete line, and you have to have good, better, best, and you need to have a 3.2 to 3.5x markup relative to cost of goods sold in order for your business model to be viable. There's all these different things that when you are a small company with less overhead, when you're mostly word of mouth and so on, that you can do things a little bit differently.
Yeah. Yeah. So I'm going to fast forward a bunch here, but you decided to create a brand called Thesis Bicycles.
Yep.
And when did that come into the world? Was it 2018?
Early 2018, I flew over to Asia, did a whirlwind several week tour, 3 factories a day in mainland China and Taiwan to set up the supply chain, decide who we were going to work with, build a bill of materials, came back with a suitcase full of parts and built up a prototype. And then you'll probably recall, I had that raw black frame that I had a decal cutter that I cut decals for. And then I had all the parts, and then I was loaning this bike out and asking people, would you buy it? And enough people said yes. And I said, okay, well, here's the website. And enough people actually put their dollars down where it made sense to start a company around it.
Yeah. And people keep saying yes to the Thesis bike. I mean, it's one of them that's in my quiver in my garage that I still enjoy to this day. I mean, it's super well executed. And I think my opinion of the bike has been well documented. One of the things along the way, you decided it was going to be a direct to consumer brand. You sourced a bunch of components primarily to make sure that every rider could get the precise fit that they want. I know you're a big advocate of differing the crank length size, for example. Handlebars are an obvious one, but crank length is one that often gets overlooked, and you get incredibly short riders still riding 172 5 cranks. In addition to those components, you also developed a Thesis wheel line, and I wanted to sort of talk about that a little bit, because obviously as we go into what's next, you have a history making wheels. So when you made that Thesis wheel set, what were you going for at the time? And as you embark on this new brand that we'll mention very shortly, we can talk about what your goals are for that.
Sure. Well, actually, my wheel building history goes back a little bit further. I built my first wheels when I was 18 for myself, not knowing anything. So literally ordering parts out of QBP, and I had some XT hubs and a Mavic rim and researched each component. And I built a set of wheels that held up. Later on at Specialized, I was charged with revamping the Axis line, which I don't know if it's still this way, but at that time it was basically their non-Roval house brand for all their more entry to mid-level stuff, and was able to talk to the wheel engineers at that time and really learned a lot from them. I read a pretty well-known book called The Bicycle Wheel by Jobst Brandt, amongst others, and kind of learned a lot of the physics of wheels at that time and the cost structure around them. And then with Thesis, those wheels, I just kind of incorporated all the best practices in terms of component selection and engineering and so on. And in fact, if you look at what we did for Thesis, you see a lot of that DNA in Lōgōs. Lōgōs takes it a step further, but it's a lot of the same principles.
Interesting. Yeah, so I think it's a great opportunity to introduce your new brand. Why don't you just give us a little bit of an overview of the brand and what it means to you?
Sure. So the brand is Lōgōs, Logos, which is a bit of a play there, right? Bike industry is notorious for just slapping some logos on things and throwing a bunch of marketing at things. But Logos is the concept of Logos. It's a Greek philosophical concept implying a reason or discourse, especially a reasoned discourse. And even deeper than that, the underlying principle of order and knowledge that underpins reality. The idea for Logos actually came from Sam Jackson, our head of brand, who's been with us for almost since the beginning, and it really deserves a lot of the credit for the brand identity and voice and a lot of the vision for the brand. Can't say enough how pleased I am with the work that he's done. But this idea of Logos being first principles based, which very much aligns with Thesis as well. There was a strong point of view, again, itself built on first principles. And it ties into other concepts that are very much aligned with how I see the world, and it ties to Taoism and Zen that this word Logos is imbued with.
That's exciting, and congratulations on the recent launch. I know
Thank you.
you to be very meticulous, and I know for the listener, you're passionate about sharing knowledge. So I think it would be great to just talk about what makes a great wheel to begin with, because whether they're buying a Lōgōs wheel or something else, the listener needs to know, how do they need to think about the wheels that are underneath them?
Sure. The reality is that wheels, arguably more than any other component in the bike industry, there's a huge number of brands, there's a ton of marketing, a lot of storytelling that may or may not be based in reality or in science. And so, of course, what we do reflects my philosophy, reflects our team's philosophy. But I think that a lot of these principles are fairly universal. So I'll try to keep it at a higher level. So we look at it in terms of performance, strength, reliability, and serviceability. And we're calling the wheels we're launching with the Omnium collection. And Omnium has this concept of a high degree of versatility, right? Excelling at a wide variety of disciplines. So there are 3 different wheels, a 700, a 650, and a 29. We'll talk about the specifics in a moment, but we can go into components. You want to start with hubs?
Yeah, I think that makes sense. I mean, and I don't want your comments to be lost on the listener. I think wheels, God, I feel like ever since I started in the sport of cycling, wheels have always been regarded as like something that if you invest a little bit more in, you get a lot more out of it. So it's interesting to think a lot of us, when we buy bikes from a bike shop, you're just going to get the wheels that come to it. And it takes a while before you start to think about getting a replacement set of wheels or a second set of wheels. One of the interesting things I've always found about gravel cycling is a lot of us come into the sport thinking I'm going to get 2 sets of wheels right off the bat. So I do think, and I can speak for my personal experience, like I've thought more about wheels than I ever have historically in any other sector of the sport, primarily because when I got my first proper gravel bike, I was all in on getting 2 different wheel sizes.
Yeah. And in fact, one of our core theses, if you will, when we started Thesis was that you could have one bike that does nearly everything and 2 wheels were core to that. And we saw, I mean, we still see about a 50% adoption rate on 2 wheel set amongst our riders. And we encourage people before they start looking at an entirely new bike, well, consider 2 wheel sets as a way, as long as you have the tire clearance, of a way of getting more utility out of the same bike, instead of having a road bike and a cross bike and a gravel bike and all these other bikes that if thoughtfully designed and thoughtfully curated from a spec standpoint, can actually serve all of those purposes really well. It's really an
Yeah.
Omnium bicycle.
Yeah. So if we're starting at the hub, I mean, for many of the uninitiated, the hub is a bit of a black box, right? As long as it's working and the bike is rolling forward, the bike you're buying off the shelf, you're not thinking too much about it. But what should people be thinking about with respect to hubs?
Well, hubs are a major point of failure. And there is a lot that goes into making a good hub. And there are certain designs that are better than others and certain designs that have inherent trade-offs. I mean, every design has inherent trade-offs. Some of those trade-offs are, well, we'll talk about, like, if you want reliability, you want strength to weights, you want something that's serviceable, you want something that performs well. Well, there are certain designs that really aren't necessarily amenable to that. And then other designs that are, but they have other constraints. So there are pawl-based systems. These are systems that have spring-loaded pawls that press against an outer ring that has teeth in it to engage when they're turning. And this is a very common hub design. You see them on the very entry level. You also see some higher end versions of them that are out there and that tend to hold up better. But they all inherently have the same issue of, if you have three pawls, one of them doesn't engage properly, or maybe there's a little bit of wear, some contamination, well, then all the load is going to potentially just one of those pawls. And so instead of having three pawls to spread that load over, now you just have one, and that's when they tend to detonate. They tend to fall apart. And then additionally, a three-pawl design doesn't have the same peak load strength, never mind the resiliency against misclocking or contamination of the next one, which I'll talk about, which is a ratchet system. So the most famous ratchet is the Star Ratchet. This was patented by Hugi in the 90s and then popularized by DT Swiss. Folks here will have heard of the DT 350, which we used on our thesis wheels, and then the more expensive DT 240, which achieves a lighter weight by using higher end materials, but otherwise is functionally identical. And the original design, which I would argue is superior to newer iterations, has two ratchets that are independently sprung, such that when they are rotating, if one of them were to get jammed or misaligned, the other one can still adapt to fully interface with the one that's not perfectly aligned. So you get full engagement, and it's very unlikely where you have a situation where all the teeth are not engaged. So
Yeah.
you with me so far?
Yeah, I am. And I'm having a little bit of a smile on my face because I do remember the Hugi hub back in the 90s. I may have actually had one. And I remember it was the loudest hub of anybody I knew, which I took a little bit of pride on my mountain bike. But it was always regarded as something that the design was, you can't say failure proof, but very, very reliable.
Well, and two things about that. One, newer iterations are not as loud unless you have the 54 tooth versions. And then secondly, there's a very good chance that that hub is still on the road. James Huang over at Cycling Tips called hubs with this design the world's most reliable hubs. And they have a reputation for that for very good reasons, what we just discussed. They are very resilient against all the sorts of failure modes that you might see with other types of systems. Now, the patent for that expired a few years ago. And this was one of the reasons why we saw an opportunity to start a company, because on their higher end stuff, companies like DT and others have migrated towards a single sprung mechanism. And there were some issues with that. They actually had not a recall, but a service bulletin put out, because when you have only one side sprung, if that one sprung ratchet gets jammed or is not properly aligned with the fixed ratchet, with the fixed interface, the teeth won't engage and you'll get wear or non-engagement.
Is the decision to go that route a cost savings?
Not cost savings. I think it's twofold. I think the primary driver, honestly, is probably that you need to have something new. And if your thing goes off patent, then being able to point to something and say this new thing is better is useful. And there are some advantages to what's called the EXP system. I think they were able to shave a little bit of weight. They were able to push the main bearing outboard slightly to distribute forces a little bit better on the axle, at the expense of this gold standard reliability. And part of it is tolerances. So you need to have much higher tolerances on a product like that, because you only have one ratchet that's moving. So if it ever gets jammed, that fails, versus with dual sprung, if one of them gets jammed, as we said, the other one can slide to meet it. It's just something inherent about that design. that will always be true. And there's a bunch of different iterations of it. And if it's executed well, it can hold up, it can perform well over time. But one of the things that we believe in is if it ain't broke, don't fix it. There wasn't a problem with the dual sprung mechanism, and in fact, it has some advantages. So that's your single sprung mechanisms. And then the other one is Sprague clutches. So this is a hub like Onyx. You're familiar with them?
I'm not familiar with them.
So without going into the details of how a Sprague clutch works, the big advantage of a Sprague clutch is you get instant engagement. Now, that instant engagement is something that a certain subset of like trials riders and some mountain bikers seem to swear by. I think that, for at least from my perspective, the obsession with instant engagement is a little bit overblown, and there can be some downsides with kickback on certain suspension designs. Plus, they tend to be heavier, a little bit more draggy, a lot more complicated. There's a lot more parts in a hub like that. But if you need something for that application, that's not a bad way to accomplish it. Now, I've put the dual sprung star ratchet on this pedestal as what I think is the best, right? But these other ones have advantages too. So instant engagement with the Sprague clutch, with a Paul-based system, there's ways in which you can design that where you can get effectively instant engagement as well. And so if instant engagement is really critical for you, well, with a star ratchet design, we use a 36 tooth star ratchet, which 36 tooth, 360 degrees of rotation divided by 36, that's 10 degrees of engagement. We find that that's kind of the sweet spot where you get a high degree of strength and reliability and long-term durability together with engagement that's plenty quick. But if you want instantaneous engagement, you're probably looking at Paul-based or Sprague clutches, and then just accepting the compromises of more complexity, less reliability, more weight, more drag.
Yeah, it's always interesting from a business perspective when you layer in that patented technology component of it. That was on lock until, as you said, I think it was last year that patent expired and allowed other people to build in that way. Because until that point, if you were building a wheel and you wanted to, do something similar or not pay those licensing fees, you had to go through these efforts to kind of design something new that inherent with everything is going to have compromises and positive things and negative things about it. So it is interesting. It'll be interesting to see going forward if some of those companies that invested a lot in these other technologies actually just adopted a dual sprung floating star ratchet because it's off patent and they can do so now.
I mean, there are a few others that are out there. Execution matters, tolerances matter, the quality of the material, the quality of the machining, the quality of the heat treatment process. So the design of it is only one part that goes into making a great hub. One of the other things that I want to call out that I really like about this dual sprung star ratchet is because it's been out there so long and because it's so established. I mean, these have been used in Roval wheels and Bontrager wheels. NV used to spec DT hubs with this design. There's tons of parts out there and they're serviceable without tools. So some riders may already have parts that are compatible with our new hub set in their toolboxes because they already have a set of DT350s, the free hub mechanism, the end caps, the star ratchets and springs. All of these parts are interchangeable. So this gets into some of our philosophy around open standards. And this is effectively an open standard and arguably the best open standard. And I would argue further, the best standard period for hubs for the vast majority of riders.
So we've gone nerd deep on the inside of this hub. And if you're interested, I think you have to either look at the hub on your bike or on the Lōgōs Components website. They've got a sort of a blown out diagram of the different components that are inside there. I do think it's interesting to have in your back pocket to understand and maybe even think about what you're riding today. But there's other parts of the hub that we should probably talk about. So outside of that mechanism is the hub shell. So how are you building these hub shells?
Yeah, so one of the big things with a hub shell is, well, one, there's the material, and then there's two, how you process it. So a lot of hubs use 6061, which is a pretty standard, still a high grade aluminum, but it's cheaper to buy, cheaper to work with. So if you look in the specs of some of your components, these are numbers that you'll see. And this is just relating to the formulation of the alloy. We use in our hub shell a material called the 6082 T6. And this is stronger and lighter, but also more expensive to purchase and to process. And that T6 refers to the heat treatment process. You start with a billet of this material, you cold forge it. So these giant forging machines to forge this form. And then you heat treat that. And then you put it on a lathe to machine out all the circular parts on the internals and external of the hub. And then you use a multi-axis mill to mill out all the features. And that's the main differentiator, for example, between the DT350 and the 240 is that material and the fact that because it's stronger, you can machine away more of it and still get the same strength. And because we're making them in-house now, we're able to use the higher end material, but still put it into a product that is, in this case, grand.
Got it. And then the final component of that hub is obviously the bearings, and bearings get a lot of attention in the bike industry. Why don't you talk about your choices there, and what should riders be thinking about with respect to bearings?
Honestly, any good brand name stainless steel bearing with good seals and so on is going to work well. I'm actually going to take a step back from answering this one because I'm going to have someone on the pod to go deep nerd on bearings in the future. We did look at ceramic and found that there's not really any advantage to ceramic for the vast majority of riders who don't have sponsorship and a team mechanic, because you get a trivial performance benefit, and that performance benefit turns into a deficit pretty quickly because they wear so quickly for reasons that I'll hold off until that in-depth bearing interview.
That makes sense. And funny, on my bottom bracket for my recent build, I was sort of enamored by the notion of doing a ceramic bottom bracket, but in talking to the experts, I ended up with a stainless steel bearing bottom bracket as well.
Yeah. I made the mistake in my racing days of spending a lot of money on ceramic bearings and not having reviewed the science. And so I tend to be a lot more disciplined these days.
Better than my racing days where people were spending money replacing all of their steel bolts with titanium bolts and spending ungodly amounts of money to save a few grams here and there.
I guess you pay more attention when you're buying many thousands of bearings than when you're buying one bicycle's worth.
Yeah.
Yeah,
exactly. Well, it's coming out from the hub. We've got spokes and nipples to talk about, and then really definitely want to get into rims because I think there's a lot of kind of takeaways that people need to revisit regarding rim technology that I want to get into.
Sure. Let's start with spokes. So we use Pillar Wing 20 spokes, which is a bladed, actually more of a diamond wing-shaped spoke. And we use these not because they're aero, though that is a benefit, but because the same process that generates that aerodynamic shape is a cold forging process, effectively. It's a cold rolling process that helps to orient the grain structure of the metal in the spoke to improve its elasticity and thus its fatigue life. That spoke also has some complex strain relieving at both ends by the threads and by the head. And these are the areas where the spoke tends to fail. And with a lightweight spoke, they want to wind up. So if you're using a lightweight round spoke, as you're building it, you're going to essentially twist the spoke. But if you have a bladed spoke, you have something to grab onto and a reference point to be able to see, okay, this spoke is oriented straight. And any twisting in that spoke is, again, these are stresses that are going to result in increased fatigue and failure over the life of the spoke. So that's why we went with these ones. In Pillar, they make a great spoke out of the same high-end Swedish Sandvik material. 302 plus is the particular wire that they start with, which is what a lot of the top-end spokes start with. And it just makes for a spoke that's really lightweight, really easy to build with, and that has outstanding durability.
And you're lacing those to brass nipples. Am I correct there?
Exposed brass nipples. Yeah. We have essentially a zero tolerance policy towards aluminum nipples or hidden nipples. And the reason being that, well, first, aluminum ones, they tend to seize, split, and fail. And for a wheel to perform at its best for a long period of time, there is some basic maintenance that needs to be done, part of which is checking the tension and truing it and retensioning as needed. We'll talk in a moment about how you can reduce the maintenance that's required. But with an aluminum nipple, well, two things. One, you tend to get oxidization that results in the nipple seizing in the interface with that stainless steel spoke, right? So now you have an oxidization process, a chemical process where it's making it so it's sticking. And yeah, you can put spoke prep on there so it doesn't stick, but eventually that oxidization is going to take place. And then it's a much softer material than brass. So brass won't oxidize in the same way, and it's harder. So why would you use aluminum then? Well, it's lighter. Well, how much lighter? Well, with a 24 spoke wheel, so 48 spokes total, 48 nipples, it's like 36 grams. So for 36 grams, you're going to take a wheel that could last a really long time, and you're going to make it so that there's a good chance, especially if you ride in rain or any sort of wet conditions, that the moment you try to true this wheel or retension the wheel, you're going to have to rebuild it from scratch with new spokes. It
Yeah.
gets real expensive real quick.
That makes sense. And I will make a point on exposed nipples. I'm definitely a big fan of that. A couple wheels I've ever had that I've broken. I've been fortunate not to break a lot of spokes in my life, but I did break one on a hidden nipple wheel, and it was the most frustrating experience in my life trying to fix that wheel.
Yeah. Well, and that's a more extreme, but still common scenario. But again, being able to just tension the wheel, right? If I have a hidden nipple, I need to remove my tires. I might be wasting the sealant that's in there because everything is going tubeless now. I have to remove the valve stem and the rim tape, right? And then I need to go in and access the back of the nipple from there. And then when the wheel is all trued, well, then I got to clean up the rim so I have a nice clean surface, and then I have to retape it. I got to put the valve stems in. I need to put the tire back on, and I need to put sealant in and then reinflate it. And so it's harder to true. There's no aero benefit. This has been shown. The one tiny benefit is that you can have a slightly smaller spoke hole, but you can make up for that with just having a tiny bit more carbon reinforcement, and the added weight is on the order of single grams.
Yeah.
And so I'll add those single grams every day.
So now we're out to the rim. Let's talk about the rims. You mentioned opening up that from a size perspective, you're doing 650, 700C, and a 29er. But let's talk a little bit more specifically about the material you're using and what you're going for with these particular rims.
Well, I want to start with something off the bat before going into materials, which is bead hooks. So this is another one of those things together with nipples that we take a strong stance on. We believe that any rim that is designed and marketed to be used with a road tubeless tire should have a bead hook. There's a trend in the industry towards going hookless for these rims, and there's still tires that are blowing off of rims. And I don't believe that having compatibility charts, so like our rims are only compatible with these tires, is a good solution. One,
so to be specific, Randall, just so the listener's clear. So you're saying on your 700C rim, which may take a higher pressure road size tire, so not talking about your 40C gravel tires, but if someone's running a high pressure 32C tire, you think that beaded hooks are a safety requirement.
Absolutely. And in fact, we're not talking that higher pressure either. It's interesting, up until recently, the pressure charts would go up linearly with weight, and then they would taper off and have the same weight for a bunch of higher weights. And it's because of concerns about blow-offs. If you have a system, tires, rim, and rim tape that are all within tolerance, then a hookless system can be safe, can secure the tire properly. The problem is that there are too many variables. There's the particular manufacturer, there's the production batch. You can't check every tire. You do check every rim, so the tolerances there tend to be a lot more stable. But then let's say you have a tire that is within spec and a rim that's within spec, and even the tape is in spec. But then you have to replace the tape, and you replace it with a slightly thicker or thinner tape, or you don't apply it properly or something like that. Well, now you have a blow-off risk, right? So I think that relying on different manufacturers to stay within a very high tolerance for a part that has a very high consequence in the event that something goes wrong is just not a good approach. Hookless beads have advantages. Up until recently, they were a lot lighter, and they were cheaper to manufacture because you had a lower scrap rate, because the way that the hooks were formed, you were machining or you were having an insert in there, so on. Fortunately, we have what we're calling a high impact bead hook that adds a trivial amount of mass per rim. It's on the order of 5 grams, and it's molded in. So you can have that high impact resistance, you can have the tire retention, you can have the weight more or less on par. And the cost is slightly higher because of how it's produced, but we think that it's absolutely worth it.
Beyond these safety concerns, what am I experiencing differently when I'm installing a tire on a bead hook versus a hookless rim?
If it's designed properly, nothing.
Okay.
Because when you're installing the tire, you have that trough in the middle of the rim. And on today's wider rims, that trough is generally pretty big and plenty deep. So you just drop the bead into there, and then it pops out and sits on the bead seat, retained by a bead lock, which we also do on our rims. And then the hook is, again, helping to prevent blow-offs, which can be catastrophic.
Okay. Gotcha. Because I'm sure I've set up tires on both bead hooks and hookless and haven't really noticed the difference.
Yeah, any difference that you would notice would be a consequence of something other than the hooks.
Yeah, gotcha. Gotcha. So good, an interesting data point for people to research, particularly and specifically on 700C rims and high pressure tires. So taking that point aside, let's talk about the rims. These are carbon rims you're making. Talk about the carbon rims in general.
Sure. You have the carbon, you have the resin, and then you have how it's processed, how it's formed, right? So we're using Toray 700, 800 carbon, very common material throughout the bike industry. We're using high grade resins that, again, very common throughout the industry on the higher end. We have access to the same materials as all the other brands and vice versa. So the magic is not there per se. There is some cool things you can do with resins. That's a whole nother conversation. But the processing is really a big difference. So we have a really high precision molding process where the rim comes out of the mold free of any imperfections in the surface such that there's no coatings required. So that's 20, 30 grams of rim easily of coatings just to deal with cosmetic imperfections that our rims come out without. And then you save an additional little bit of weight as a result of the precision of the process and the way in which it removes as much excess resin as possible. Because the resin is not what's giving the rims their strength. It is the carbon, and then the resin is bonding the layers of carbon together to give it that structure. So any excess resin you can remove and maintain the same strength, right? So any excess resin is not contributing to the structural integrity of the structure.
Right.
So that's on the material side. Other things I mentioned, beadlock, asymmetry. So this is another thing that we do across our line and we'll always do across our line. The rim is basically, it's kind of biased to one side.
Yeah.
And what this does is your hubs are not symmetrical, right? So up front, you have a disc on one side and no disc on the other. In the back, you have a disc on one side and you have a much bigger, much wider cassette and free hub body on the other side. So by going with an asymmetrical rim, it helps to balance out the spoke angles and thus the spoke tensions, which means that you have a wheel that has higher average tension and total tension with the same number of spokes. And you have a reduction in the change in tension with each revolution or each impact. And these two things together make a stronger wheel that's more durable with the same number of spokes. And the impact is actually quite substantial. So we do that across the board. And think that we can't see any reason, with the exception of a wheel that is designed purely for aero. And even then, we would still do an asymmetric rim.
Yeah, that makes a lot of sense. So we've gone into a lot of detail as to the componentry and the quality of what you guys are putting together. But at a certain point, these things need to get assembled. And I know historically, like that is a challenge from a process perspective. It's like, how do you build these wheels up from these quality components? Because if they're not built well, you'll end up with a shit wheel.
Yeah. So this exactly right. There's the curation in manufacturing of the components, and how they're put together is no less important. You can have the best components in the world. If they're not assembled properly, it's not going to hold up. You're not going to get the performance out of the box, never mind over time. So this is basic things like prepping the spokes. So you have a material that helps to lubricate the interface between the threads and the nipple, right? And this is something that's basic. It needs to be done. In our case, we have essentially hand-laced machine built for a first pass. So a machine will go through and adjust and get the wheel round and true. And then we'll have a skilled person finish the wheel. And this brings it from round and true to where the tension around the wheel, one, is as high as it can be. And again, this results in a stronger wheel that also has less change in tension as it turns. But then also the spokes are as close in tension to each other as possible. And this part is actually hard to achieve. It requires a lot of skill and it takes more time and money. And then how do you validate that? Well, you machine check it. So you check the tension in every single spoke and then put it through the true and the roundest check again before going out the door.
Yeah, that makes sense. So I think we've dug in pretty deep on wheel technology and given the listener a lot to think about. I'm sure people are going to be interested in these wheels. We've talked about, all three sizes are going to have asymmetric rims. The 700C is going to have a high impact bead hook for the reasons you mentioned. The other two are going to be hookless. The one thing we haven't talked about has just been the width. And I have found that in other conversations with other wheel manufacturers that's an interesting area to talk about and just kind of nail home, why we're seeing some of the gravel wheels go wider in the width of the rim than, historically was part of, road and road plus bikes.
Sure. I mean, this is a trend across the board. And in fact, it's been taken a little bit too far in some cases. There is a Goldilocks spot.
Which I think is great. I think that's one of the great things about gravel is like we've been, and component manufacturers, like they've been pushing the extremes to figure out where the sweet spot is.
To figure out what the sweet spot is, but then also to meet what the market is telling them to make and not really sticking to first principles. It's like, oh, people have a perception that wider is better, so let's keep going wider.
Yeah.
Right. Just like lighter is better, let's keep shedding weight. And then a year down the road, let them worry about it. But in terms of widths, the sweet spot, I would argue for a 700C wheel is 23 to 25 millimeters. Right. And you see a lot of wheels coming out in that range. Ours are 24. And again, with these bead hooks. And you can run down to a 28 millimeter tire with a 24 internal width, and it'll be secure and it'll be properly supported. And a 28 or a 30 will be aerodynamically well matched to that rim, which will have an external width of 32 in our case, which, by the way, we'll talk about aero in a second. And also being able to support the higher end of the range. So in the case of narrower tires, you want it to be aerodynamically matched. On the case of bigger tires, you just want it to be wide enough to support that tire at low pressures without tire squirm and to give the tire a good shape, as opposed to a light bulb shape that you're engaging the side knobs of the tire maybe a little bit early and so on. And tire design has had to evolve together with rim width, but as a system, it's definitely an improvement. And the sweet spot is really in this 23 to 25 millimeter internal range.
Yeah. Yeah.
For a 700C rim.
I think that light bulb shape of the tire is kind of interesting. It was an interesting visual for me to initially get introduced to, and how the wider rims have kind of made that shape less pronounced, and you do get more performance out of the tire, I've found.
And this is enabled substantially, or it's required with the lower pressures that tubeless is allowing. So remember, the original ETRTO standards, the European standards body, for narrower rims came out at a time when everyone was running clinchers with tubes, and you had to run higher pressures because otherwise you would pinch flat. Well, now you have tubeless tires, so you can push the limits of pressure, but once you drop below a certain pressure, if you're not properly supported by a wide rim, that thing's just going to squirm around. So that's what kind of forced this issue.
Yeah, gotcha. And I was, when you mentioned your new efforts around Lōgōs components, and you mentioned you were adding yet a third wheel size, I was actually a little bit surprised. So can you talk about adding the 29er wheel into your lineup?
Sure. Before I do, I want to close out one thought on the 700Cs because it's relevant, which is aerodynamics. And this kind of applies across the board, but especially 700s. There's a rule of 105%. And this rule essentially states that your rim has to be 105% the width of the seated tire, not what's stamped on the side, but the tire as it's actually measured on the rim when it's seated, in order for there to be any significant aerodynamic benefit. Which is to say, let's say you have a 50, 60 millimeter deep rim, and you're like, oh, it looks so aero, it looks cool, but it's really narrow, and you run a 28 mil tire, and your rim is only 28 or 27 millimeter wide. Most of the aerodynamic benefit you're losing because the airflow is becoming detached before it even gets to the rim. It's detaching as it goes around the tire. And this is even more so for gravel. Fortunately, we're seeing less of this, but aero gravel rims is just marketing. In fact, if anything, it's just giving you more turbulence in a crosswind. So the rule of 105%, that's just physics, and everything else is marketing unless you're adhering to that. The 2.9, so we built wheels with Thesis specifically for our bikes. And when we did this program, we wanted to have a 3-wheel quiver that covers the full range of experiences. And so the 2.9 wheel, it's built to a trail standard. It's a 31 internal versus the 24 of the 700C. It's designed to take tires anywhere from 2.1, 2.2 on the smaller end, all the way to 2.6. And again, it's going to be wide enough to support that range of tires at a wide range of pressures. It's light, but not super light. It's 1,565 grams, which is on the heavier end of cross country, in the intermediate lighter end of trail, but we wanted something that would just be bomb proof. It's light enough to race, but will hold up for all your training. And when you're underbiked and you hit something sketchy, it's gonna hold up as well.
Yeah, so obviously there's some gravel bikes like the Salsa Cut Through It that run a 29er wheel, but just so I'm clear, so this is a proper, in addition to servicing that market, this is a proper mountain bike wheel.
Oh yeah. So when you think about the types of gravel bikes that are using a 29er wheel, they're generally more expedition type bikes. Otherwise, you'd be better off on our 700C Apoge. So the U-Day 29 is very much a wheel that if you were going and doing an expedition, this is a great wheel to bring. Because even though it's on the lighter side compared to some wheels in that segment, you have the asymmetry. The weight is being saved through materials and precision engineering and manufacture rather than compromising on structural integrity. And one thing that's true about all these wheels, by the way, is each wheel set uses a single length of spoke, which we include a spare with it. So if you ever did have an issue, being able to change a spoke in the field is about as simple as it could be.
Yeah, gotcha. Super interesting. Well, we've gone deep on wheels. There's a few more things I wanted to cover, but I think we're running a bit long on time. Is there anything else in parting? This is a big week, probably when you listeners hearing this, a week behind us, but you've got Lōgōs components off the ground. We'll certainly put a link in the show notes. Is there anything else about the brand or the ethos that you wanted to share with the listener before we sign off for today?
The long and the short is you have to have a reason for existing. And in our case, we saw an opportunity to make something that fit our perspective on what the ideal wheel would be and to pull it off at a price point that is affordable to a much bigger audience and to provide some education at the same time. So if you're curious about any of the concepts that we discussed here on the pod, I know we went pretty deep nerd here. Components.com, hop in there. We've created some materials there to make it easy to get one's head around these things, and it applies to wheels more generally.
The last thing is I really want to thank all the stakeholders who helped to make this happen. This is particularly Sam Jackson, our head of brand, who I mentioned before, as well as Angela Chang, our head of operations.
This is our vendors. This is various industry experts who've provided their 2 cents. This is the ridership community, many of whom I assume are listening, who contributed their thoughts when I first posted the idea for this project some months ago and got a lot of positive feedback and, in fact, quite a few pre-sales. So can't thank you enough. And then, Craig, the first conversation that we had was really the tipping point with thesis in terms of providing an opportunity for people to get to know us and to see our philosophy and how we approach things. And it's been immensely gratifying to be on this journey with you, first as a guest, and then now as someone who gets to do episodes, not just with you, but then explore ideas with guests that I bring on myself. So a lot of appreciation. We would not be here if not for the support of those parties, and we feel excited about what the future holds.
Well, cool. I mean, best of luck to you and the team. It's always great to see. I have always enjoyed your philosophy around the transparency of what you're doing and your openness to have discussions with people. I think whether it's the Thesis brand and I'm sure the Lōgōs brand, you have an openness for discussion with people who are considering the products, and whether or not they choose your particular product, I think they'll understand your point of view and your commitment to providing and creating the product that you've arrived at in your mind. So kudos and congratulations. I look forward to continuing the journey with you. Obviously, we'll have you back on for the listener. You'll be back on here for Into Dirt episodes in the future, and also doing deep technical dives around both bicycle componentry, but also the philosophies of community and general philosophy of what cycling brings to our collective lives. So
yeah.
Good to talk to you as always, Randall. I wasn't surprised that we went a little bit longer today, but hopefully the listener can give us a little bit of room there for enjoying our conversations together.
Yeah, and if anyone has any questions or comments, please jump in the ridership in the Lōgōs channel or drop us an email.
Cool. Thanks, Randall.
All right, thanks, Craig.
That's going to do it for this week's edition of the Gravel Ride Podcast. I hope you learned a little bit more about Randall's background and are excited to check out Lōgōs Components. I know you can learn a lot just simply from visiting the website. As I mentioned, they've got that breakdown diagram of the hub, which I found very interesting if you're curious about what a star ratchet looks like inside. Big thanks to our friends at Hammerhead and the Karoo 2 computer. Remember, use the code TheGravelRide to get that free heart rate monitor with the purchase of your Karoo 2 computer. If you're interested in connecting with me or Randall to ask questions about this podcast or otherwise, best way to do it is simply join the Ridership. It's a free global cycling community. It's at www.theridership.com. You can interact with the two of us, but also more importantly, thousands of other athletes around the world to answer your questions and share your joy and share routes from around the world. If you're interested in supporting the podcast, you can visit buymeacoffee.com/thegravelride, where ratings and reviews are hugely appreciated. Until next time, here's to finding some dirt under your wheels.